Hey guys, welcome back to day 2 or part 2 of Target 1A. So in part 1, we looked all at dilations and scale factors. This is really about similar triangles. Remember, when you looked at the vocab, we have 3 ways of telling that triangles are similar. The angle-angle postulate, the side-angle-side postulate, and the side-side-side postulate. So the first thing we want to do is know if we have similar triangles, what are their similar parts, or what are their corresponding parts. Okay, so our corresponding angles, right? You're going to have 3 angles that are corresponding. And remember, corresponding angles in similar triangles are congruent. The easiest thing to look at is the name, not always the picture. If you're given that similarity statement, look at the name. It's a good hint. Because I'm just going to start with what my first triangle starts with an M. So that's the angle I'm going to look at. Angle M, and I'm going to say that's congruent to, again, the first letter in the second triangle, angle F. Okay? And remember, we can use these little marks to mark similar or congruent angles. Since those are congruent, they both have one little tick mark. Okay. And I'm going to do that for all my angles. I can just go down the line. Angle N, the second one, is going to be congruent to the second letter in the second triangle. So angle R. They're in the same spot in the name. So N, 2 tick marks, R, 2 tick marks. And then the third letter, angle P, has to be congruent to angle T. Okay? So P, we'll give it 3, and T will have 3 as well. Okay? So those are my congruent angles. Then I'm also going to have 3 sets of sides. However, remember, these are similar triangles. They're not congruent triangles. So their sides are not congruent. Their sides are proportional. So how I'm going to write that is, if you look, I'm still going to go off what the name of the triangles are, this part up here. But remember, lines or sides have to be named by 2 letters. So I'm going to start with the first 2 letters, MN. So this side is in proportion with the first 2 letters, SR, this side, right? So MN is in proportion with SR. So I write them as that ratio. And that's going to be equal to the ratios of my other side. So I did the first 2. Now I'm going to do the second and the third letter. And P is in a ratio with RT. Right? So sometimes it's easier to look at the name than the triangle. You can still look at the triangle sometimes. Sometimes it's easier to do it from the triangle, but they both can work. And then finally, I did the first and the second. I did the second and the third. So now I'm going to do the first and the third letter. So I have MP and ST. So that's how I would write my 3 sides. They're not congruent. They're proportional. All right, looking at example 10. Ooh, I jumped. For all 4 of these problems, you want to say, are these triangles similar? And if they are similar, state the postulate that proves it. Right? So remember, our 3 postulates is they have to have 2 angles that are congruent. Right? That's angle, angle. They can use side, angle, side. They have 1 congruent angle, and the sides surrounding that are proportional. That's like what we were doing up here, where their ratios are equal. Okay? Or we have side, side, side. And again, that's like up here, where all 3 sides have that proportion. So looking at A, I know a lot about angles. I don't know anything about sides. Right? So I'm pretty much going to cross off. I know I'm probably not going to use side, angle, side, or side, side, side. I'm really going to look for angle, angle. So sometimes making those decisions early will help, right? Just canceling out and not having to worry about side, angle, side, or side, side, side. Okay, I'm really just going to look at angle, angle, because I only know things about the angles. Okay? So I already see one congruent angle. They both have a 70-degree angle. So I have one of my angles, but I don't have the other. Yes, right? Right here, I only know this 30-degree angle. I have no idea what K is. K could be 85, or P could be 30. So what I'm going to do is I'm going to solve for my missing angle, using what we talked about the other day, the triangle angle sum. Right? All angles in a triangle add up to 180 degrees. So for this, I have 30 plus 70 plus K has to equal 180. Okay? So 100 plus K equals 180. So K has to equal 80 degrees. Right? So this angle is 80 degrees. Well, 80 is not 85. So that kind of already eliminates it. I'm already thinking, oh, I don't think these are similar. But let's find angle P. Let's just double check to be sure. Okay. So I have 70 plus 85 plus P has to equal 180. Right? So 155 plus P equals 180. Right over there. So P, right, subtracting that 155 has to equal 25. Well, that kind of proves it, right? They only have one set of angles that are the same. Their other angles are not equal. So all I'm going to say is no. These are not similar. All right, looking at B, one thing already jumps out at me again. I see 45 and 45. Okay. So I know it's not going to be side, side, side because I already know that an angle is congruent. So I'm probably not going to use side, 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 or at least that's not the easiest one to find. So I'm either going to be using angle, angle, or side, angle, side. So you either have to find one more angle that's congruent, or I need to show two sides are proportional. Well, I don't know anything about the sides of these triangles, so I'm probably not going to use that one. It's probably going to be angle, angle. So let's see. Can we find another angle that's congruent? Well, again, remember that vocabulary we went over. We have these things called vertical angles. When two lines intersect, the angles opposite are called vertical angles. And if you remember, vertical angles are congruent. So since these angles are opposite of each other, I can just say, oh, I know those are congruent too. They're vertical angles. Okay? So since that's true, now I do. I have two sets of angles. I have the red set and the blue set. So, yes, these triangles are similar. And I'm going to say by, angle, angle. And you do not have to write the whole thing out. If you say these triangles are similar by AA, I completely understand what you are talking about. Okay? So these are similar by, angle, angle. Let's look at C. Okay? Now, for C, I know nothing about the angles. A lot of students get tricked because they go, oh, well, it's a right angle. If it does not mark it, you cannot say it, right? Unless it has that little square marking showing that it's a right angle, you cannot assume. That could be an 89-degree angle, right? And that one could be 90. You cannot assume that two angles that look similar are similar, or two angles that look like 90-degree angles are 90-degree angles. So be very careful with what you assume from a picture. You really shouldn't assume anything from a picture. Okay. So looking at this, again, like I said, I don't know anything about the angles, but I have a lot of information about the sides. So I'm probably going to be using that side, side, side postulate to show that these two are similar. Okay. So the easiest thing to do when you're looking to see if two sides are similar, a lot of students are like, well, which sides do I compare, whatever. Look for the smallest. I'm going to look at my first triangle and circle the smallest side. That's 6, right? Same thing on my second triangle. If they're going to be in proportion, the smallest has to go with the smallest, right? So I'm probably going to be using that 9. Remember, kind of keep it in order, second over first, right? Just like we were doing with our scale factor. That's pretty much what we're doing here. We're seeing if the scale factor is the same for all 3 of these sides, or that proportion is the same for all 3 of these sides. Right? So I have 9 over 6. And that should, sorry. Okay. Let's break it out. There we go. All right. So then, all right. So then I'm going to choose my next biggest side. Right. So I'm going to move up. So 6 and then 8. Right. That's the next biggest side. Alright, so I have 8, and then the next biggest side on my other triangle is 12. So same type of thing, second over first, 12 over 8. And for these, it does not matter as much as the scale factor. The scale factor is really important. These you can flip as long as you start with the same triangle every time. Okay? You can't do 6 over 9 and then 12 over 8. It's going to mess it up. So if you start with one triangle, you always have to start with that triangle. And then my last side, I have 10 and 15. So I'm going to start with my second triangle. That's 15 over 10. Now, I just want to see, are all of these equal, right? These have to be equal. So I have to reduce the fractions to see if they're equal. So 9/6 is 3/2. So 3 over 2. 12 over 8, if I reduce that, it's also 3 over 2. And 15 over 10 is also 3 over 2. So are these triangles similar? Yes. And that's by side, side, side. All right, let's look at our last example, example B. So if you look at the example D, the only thing it tells me, right, the only things I have written are sides. And I only have 2 sides. I don't have this third side over here, right, on either of my triangles. So I think side, side, side would be pretty hard. I don't have that third side. So maybe I have 2 sides, so maybe I want to look at side, angle, side. Right, well, I know that I have these 2 sides, but what angle do they have in common? Right, well, if I look at my 2 triangles, I have LKP, and I have MKN. Right? Well, if you look, they both are using that angle K. So that's actually the angle that's congruent, because they have the same angle. That has to be equal to each other. So they're both using that angle K. So there's your angle. So now all I have to do is check if my sides are proportional. I'm going to start with the red triangle. On this side, that KL side, I have 8. And in my blue triangle, be careful, I have 8 and then another 2 for a total of 10. Right? Back to my red triangle, because anyone I start with, I have to start with always. I have to do my other side, which is 12. And then in my blue triangle, again, be careful. If I'm doing this whole length, it's 12 and 3, which is 15. So then, all I'm doing is checking if these are equal. 8 over 10 reduces to 4 over 5. 12 over 15 reduces to 4 over 5. So this is also, yes, these are equal, or these are similar, by, and this one's side, angle, side. Alright, that's it for target 1A. We're done with that notes for that one. So again, make sure you come in with your questions on all our triangle similarity stuff for tomorrow.